Hi everyone and welcome back to Maths and Physics from Mr. Simons. Today's lesson on grade 12 statistics is an introduction to bivariative data and how we draw scatter plots, how we find correlation coefficients, etc. Right, so the primary purpose of bivariative data is to compare two sets of data or to find a relationship between these two variables. Right now, this data is often analyzed via the use of scatter plots. So, I'll give you an example. Internet-based company recorded a relationship between the number of marketing emails sent per week over a period of 8 consecutive weeks and the number of products sold based on these emails. So here when they sent 5 emails, they sold 18 products. Then when they sent 10, they sold a little more, 23. When they sold 15, sold a little bit more, 26. When they sent 20 emails, they sold 60 products. Then when they sold 25 emails, they only sold 30 products, which is a bit weird because it dropped. But when they sent 30, it increased again. 35, it increased again. 40 increased again. So 20 is the odd one out here. But yeah, for now, let's look at how we can test you on these questions or on a table given like that. So when I say we're testing two sets of data, we check BMW performance versus the interior. Is how concerned are you the interior compared with the performance? Other people, color compared with how the cars sound, etc., etc. All right, we look at all these things to make sure that when we sell products to you, even nowadays with what they call marketing, online marketing and so on, digital marketing, right? They have to verify all these things so that we can get customers and we sell our products and everybody makes money and we're all happy. Right, so we have number of emails, number of products sold, and they say draw a scatter plot of the data given. Right, so we need normally first row, or then the top would be on my x-axis and second row would be on my y-axis. Right, so there I have number of products sold and I have emails sent per week. I have 5 and 18, so here we have 5, I have 18, then I have 10 and 23, there's 10 and 23, then I have 15 and 26, 20 and 60, so if you look at 20 and 60 is way off. 25 and 30, 30 and 40, 35 and 50, and then 40 and 55. So that in short, we're just plotting dots, and that is what a scatter plot would look like. Right, now if you go to second question, calculate the equation of the least square regression line, which you normally do on calculator. Right, so determine equation of the line of best fit or regression. So line of best fit is also called a regression line. Equation is given by y equal a plus bx, where a is the y-intercept and b represents the gradient of the slope. Please note, in general, we exclude the outlier when calculating the line of best fit. There you could see that 20 and 60 was a huge outlier. Right, so if you have a Casio calculator, you're going to press the mode button. Then you're going to press 2 for stat. Then you're going to press 2 again and choose a plus bx. Then we enter the data points. So in the one column, we're going to add 5, 10, 15, 20. So we're going to press 5 equal, 10 equal, 15 equal, 20 equal, 25 equal, all the way to 40 equal. Done there, we're going to do the second column, 18 equal, 23 equal, 26 equal, 60 equal, 30 equal. Okay, the 20 and 60 I have to exclude, but 30 equal, 40 equal, 50 equal, and 55 equal. I've done entering my points. I then press AC. Then I'm going to use the shift button there on the top for second function. So shift, press 1 at the bottom of your calculator. Then I'm going to choose 5. It's got RHE there. Next to it, once I've selected it, then I press 1 and I select A. So that gives me the A value. Right, once I have the A value, I write it down and I press shift 1 again, 5, and this time I press 2 to get the P value. Right, when I'm done, I can just press AC or then press mode 1 to get back to normal mode. So doing all of this on my calculator, the A and B I got 22,5 and B equals 0,21. So if I substitute in that to the 22,5 plus 0,21x. So that is my equation, right? So that is how we get it. You can pause here, look through it, get used to using your calculator. So to plot the least square regression line, a very important principle is that the line of best fit passes through the mean. So there's the mean of x. I'm adding all the values there, 5 plus 10 all the way to 40, divided by 8, which gives me a 22,5, which is approximately 23. For the y-axis, my mean, or for my y values, my means, if I add everything together and divide by 8, I get 37,75, which gives me 38. Alright, so you can go double check there that I've taken straight from the table that we've worked from. So the line of best fit must pass through 23 and 38. So in order to draw the line of best fit, I find the y-intercept from the equation and a mean point and draw the line through these 2 points. So similar to the dual-intercept method. Right, so there my y-intercept from the equation we got, it was y equal to, I think, 22,58 plus 0,21x. So if x is 0, y is roughly 22,5. There I have a point 23 and 38, so if I take 23 up there, it's roughly by 38. Take note, not drawn to scale. Ne? So there's my point, and there, so if I draw, basically here from 18, I draw right through, basically till 35, and there I have my line of best fit. Right, mine not drawn to scale. Drawn to scale, a lot more points would be closer to the line. Right, because they'd almost give a perfect straight line. Right, so I hope you follow, but that's how we draw a line of best fit. Then with this, we'll always have what we call the correlation coefficient. So let's go look at the next question. Calculate the correlation coefficient and comment on the strength of the correlation. So for correlation coefficient, if we have a Casio, we press mode 2. Then we press 2 to choose A plus BX. Again, we add the data points. We exclude the outlier, that 120 and 60. 1 into column X, then column Y. Then press AC. Now you're going to press Shift 1, 5, and we select 3 where R is. Right, so once we've done with all of this on my calculator, I get R equal to 0,96. Now this here, if we have to comment on the strength, is called a strong positive association. Alright. If you want to, we have the following table that provides different examples. So if it's 1, it's a perfect positive association. 0,9 strong positive, 0,5 moderate, so between 0,5 and say 0,8 moderate, then 0,2 and 0,4 weak positive association, 0 no positive association. Then we also have weak negative, moderate negative, strong negative, and perfect negative association. So you can pause there, write the table down for you in your book. Make sure you know it, but I'm sure your teachers have given you nice notes on it. Right, I wish you nothing but the best. God bless. Bye.